Welcome to Cloud on Air, Google Cloud's live webinar series. We are hosting live webinars every Tuesday this February. I am Saptarshi Mukherjee. I lead product marketing for data analytics, and we are joined by Eric Schmidt.
Hi, I'm Eric Schmidt. I'm a developer advocate in the Google Cloud Platform team, and I spend most of my time on data analytics and data science workflows.
Great. And we are going to talk about love. What's a better day than the day before Valentine's Day and talking about love?
Especially if you are in love.
Yeah, absolutely. And this topic is about human emotions and how do you understand human emotions, apply algebra to determine human emotions. And we're going to talk about research work by Dr. Robert Plutchik in this field. But we're going to talk about how do we apply emotion arithmetic in business and make it real to delight our customers. In that context, we're going to talk about Google Cloud's data analytics and data science platform. And then we are going to do a real demo. We're going to do real coding, Eric?
We are, yes.
Okay, that's great. Let's hope it all goes well. With that, let's talk about love. Love has been one of the most argued topic that I can ever remember. And I think that's true for many, many decades and centuries. Like we have great poets who have defined loves. We have great philosophers, and most recently, evolutionary biologists talking about love as the evolutionary necessity. So it's an interesting topic, top of mind for many people. And we have been discussing this in the context of philosophy, poet, psychology. And we're going to define love is equal to trust plus joy. And how do we come to this equation?
Yeah.
So that's the fun, right? Let's get started. So the psychologists have been trying to understand love and human emotions for decades. And one of the most cited work in this space is from Dr. Robert Plutchik, who came up with this very interesting model of human psychology called the will of emotion. And what it does, it allows us to come with resultant emotion based on underneath nuanced emotions. So for example, as per his model, love equals to trust plus joy, awe equals to fear plus amazement, and then we have contempt, which is anger plus disgust. But let's look at the model. The way to interpret this model is you have an ordinal listing of human emotions throughout this model. And the emotions which are at the very central piece of this model are the most intense ones. So if you see admiration, terror, amazement, grief, these are very intense human emotions. And as you try to move outside of the will, across the petals, the intensity of those emotions come down. And if you add the two emotions in the adjacent petals, you get the resultant emotion in between the petals. So for example, if we zoom into this particular aspect of the will, joy plus trust is equal to love. And similarly, if we see awe, it's a state of terror and amazement. And when we got to know that we're going to talk about psychology in a live webinar, it gave me a bit of a terror. But then we got to know we have a lot of people listening to us. That's a huge piece of amazement. So we are in a state of awe pretty much. With that, let's talk about what does it all mean, right? And for you, for your businesses. And so this is emotional arithmetic. And it's extremely important to understand that today's customer feedbacks about product, about experiences are getting really nuanced. It's not just okay to understand the sentiment of a customer's dialect or a customer's written piece of text. We need to understand what the customer is actually trying to convey. And that's when we are going to get the juice of that comment or the talk track and be able to kind of offer them something really, really interesting. Let's look at a real sample. So this is from our demo that we're going to do later today. This is a product review from one of our customers who's talking about one of the beauty products that the person has bought from the e-commerce site. And the person talks about that the product was great, the person got a free sample of it, the experience was great, but then the pricing was not as per the customer expectation. And at the very end, the person is hopeful, and hopefully the company is going to correct the pricing and make it a really good deal for the customer.
And this one feels like there's polar opposites here, right?
Exactly.
So, yeah.
So if you just do a simple sentiment analysis on this piece of text, you will see there are a bunch of positive sentiments flowing in the product is great and the company has done a great job. And then we have a bunch of negative sentiments that are going in. So the simple sentiment analysis is not going to give us great details. But if you go and apply our emotional will, the will of emotions, you will see there are nuanced emotions playing throughout the text. There is a level of anticipation. There is a level of joy and trust, like, this is great, I found the sample to be working really well. And then there are levels of negative emotions throughout the text, like the pricing was not right. There was a level of anger and disgust. So if we apply the will of emotion model here to understand how we can delight this customer, if you see the person has anticipation and joy, and if I merge these two, I see a lot of hope, and there is a level of anticipation that the customer has, and correcting the price may convert this customer into a great ambassador for the product.
Yep.
So with that, let's talk about real life examples of where we can apply the emotional arithmetic and understand emotion, analyze them. Online retail, we're going to show the demo and talk about how we apply there. But say, for example, gaming analytics. A lot of companies who are providing gaming titles, the gamers are all the time very vocal about their experience with these games. And if we can understand their emotions, we'll be able to offer them more personalized gaming experiences. And marketing in overall is trying to be more relevant to the intended audience, right? So it has huge application in the field of marketing analytics. Try to making sure that the campaigns and the content are as per the audience's needs. Now, if you try to analyze customers' emotions in real time, and they're coming from millions of your customers, you can't do it manually.
No, your example is great. You showed us one, but how do we do this with millions and millions of comments over millions of customers?
Yeah, and then it pretty much becomes a big data problem for all of us, right? And here is what Google Cloud has to offer in the data analytics space. And we make it really simple for our customers because our data analytics platform is serverless. So what it means is basically for you to build a emotional analytics model, apply machine learning, understand human emotions, and then apply our learning into our product personalization. You can do this pretty much end-to-end without thinking about any infrastructure, capacity planning, load balancing, nothing of that sort, because everything else, those infrastructural needs are taken care of by the platform. And as an analyst, you can just simply focus on doing your data analytics. And we're going to talk about all these tools in the context of the demo. Now, the first thing in the data analytics stack is the data management platform, where you store all your customer feedbacks, the emotions in real time as they come in. And our offering in this space is Google BigQuery. Now, BigQuery is different. It is a data warehouse, it's an enterprise data warehouse, but it was designed for an ML-first world. If you look at the evolution of data warehouses over the course of last many years, data warehouses were initially designed for a BI-first, reporting-first batch paradigm. And now, as companies are increasingly investing in data science workflows and building machine learning models from their most important data sets, the data warehouses need to live up to that expectation. And that's what exactly BigQuery does. So the first thing is, BigQuery is massively scalable. So whether you analyze your customer feedback from a few hundred customers or millions of customers, the same system is going to support your analysis needs. It is very simple to use. It supports ANSI SQL. You can write queries in the language that you already know. And it supports real-time data analysis. Like data warehouse, we typically relate to the batch paradigm, but BigQuery supports real-time streaming inserts, and we're going to show that how it works. And it's encrypted, durable. It kind of checks all the boxes that are needed in a modern data warehouse system. So with that, it's almost time for the code. Let's make it real.
Great. Thanks, App. And I want to say, hey, happy Valentine's Day.
Thank you very much. Happy Valentine's Day to everyone.
Yeah. All right. So as we get into the demo, we need to do some pre-work. Because you just can't go build an online site or a data warehouse unless you go and get data and you ingest data and start doing some analysis. So the first thing that I want to talk about is if you wanted to go do analysis, say emotional analysis over comments and orders, et cetera, you're going to have to go get data from various systems, your CRM system, billing, point of sale, et cetera. And you may use a myriad of different tools. So we work with lots of companies, and the average rate right now is that most companies use around 30 different tools to do ingestion, transformation analysis, et cetera. If your goal is to get a holistic view of customers, you end up having to use lots of tools over lots of different systems. One of the tools that we used for this demo is Google Cloud Dataflow. What Dataflow enables you to do is to point a job, a graph of instructions at some data source, read from that source, provide a set of transformations. Maybe you want to read user comments and you want to parse out all the words, or you want to load your line items and join that to some catalog information. It doesn't really matter. You just go ahead and point it at the source, run your transformations, and then load your data to some destination like BigQuery. The key here is that this is completely serverless, and it is optimized for embarrassingly parallelized operations, say like reading 100 million user comments and then loading them into BigQuery. So I use Dataflow as my step one to go ahead and read data from all of my sources. With this, I was able to then quickly get some high-level views of the data using Data Studio, which is a serverless product. It's free as well, that you can use to build real-time interactive dashboards. So this dashboard is on top of the demo called You Look Marvelous. We're going to show you that here in a minute. This view is showing me some high-level sales information, demographics. Where are my sales coming from? What's the difference between, say, online sales and in-store sales? Here's another view that we quickly built, which is how do products purchase affinitize? So if people are buying product A and they also buy product B, what's the likelihood that they would also buy product C? So I could build a simple recommendation based on basket analysis. So I was quickly able to go from, say, no data to ingesting data to quickly visualizing it. And for this demo, what I want to do is kind of flip the analysis. Instead of focusing on just the customer view or the product in terms of the sales aspect of it, I want to understand, why did they buy a product?
Yeah.
Was it effective? Would they buy it again? Because ultimately, the more I can learn about the user's behavior around the journey that they took to buy a particular product, I could potentially influence a new purchase, a new user that's coming to my site. So how do things work today? So SAP, you showed that example of reading one user comment, and this is what we're going to show you in the demo. How things work today is usually you go into a site, you would type in a free search, or maybe look at the taxonomy of that site. You're trying to find a product. So maybe I'm trying to find some cream for an acne problem. And I'm going to get a bunch of search results that are ranked on that site, typically by most popular, by price, et cetera. And I start looking at the ratings, and then I look at comments, and I keep doing this process over and over again. And it might take me 25, 30 minutes for me to decide whether or not I'm going to buy this product. Now, so let's play a game. SAP, you showed the one that you previously scored, right? But in this case, we don't have any of the dramatic, struggled, 2 times, skin, definitely, et cetera, et cetera. This is where us as humans, we end up spending our time and also emotional energy to figure out, is this comment a good comment for me in order to make a purchasing decision? So what if we showed you the results on that site that were ranked by sentiment and effectiveness versus top selling? We could potentially show you products that are more appropriate for you higher in the rank. And then what if we showed you comments once you were looking at a product that were more appropriate for the product that you were looking at? So we could ultimately shrink down the overall kind of purchase time, and we could also provide you a more effective cycle to influence the best possible purchase. So now that we understand the context, let's get into the demo. The first thing I want to show you is our You Look Marvelous site. This is a fake demo built with fake products, but these products actually exist in the real world. I just anonymized all of them. So here, I'm going to go ahead and search for skincare and treatments and blemish and acne. So I'm going to go out and do a search, and you'll see that the sort order up here is called my You Look Marvelous score. Now, typically, this may be sorted by price or social popularity, but now I have this You Look Marvelous score. And you can see right here, this product, the Sail Holid Still Max treatment, has a 47% You Look Marvelous score. Now, take a step back and like, well, 47%, that sounds low, but it's the second ranked top product. So if I go ahead and I click into this, it's going to go out and retrieve all the product information for that particular product, pull it back. Here's the product. This is what it says it's good for, and I'll start scrolling down. And you can see that this product has an overall rating of 4.24. That sounds pretty good, right? It's got 105 five-star ratings, and you can kind of see the distribution of the other ratings. So right here, if you were just looking at ratings, you'd probably be influenced like, hey, this feels pretty good. This may be a good product for me. But what we've also done on the You Look Marvelous site is we've taken all of the underlying comment information and ran it through our emotional analysis workflow that SAP was talking about. And now you can see the distribution of emotions. So you can start making decisions like, well, there's a lot of positivity around this. A lot of people loved it. A lot of people are, say 3% are showing anticipation, but there's also a decent amount of negativity, right? And in the real world, nothing's going to be perfect. You're always going to have products that have some type of distribution between positive and negative, and then various aspects of emotional rating. And the last thing to show you here is the comments. So these first 3 comments, we selected them based on some psychological knobs that we built to determine what comments are the most positive and are also the most information dense. So as a potential purchaser, this is where we spend a lot of time. We're reading those comments trying to figure out, is this the best comment for me? What happens if you didn't have to do that? On the You Look Marvelous site, you don't. These comments are the comments that are the most appropriate from an emotional aspect related to the product's reported goals, as well as the comments that have the most information density inside of them. So kind of keep that in mind. So this is kind of how we built this You Look Marvelous score and how we tried to improve the overall shopping experience. Let's look at how we did that. So I talked a little bit about getting data into BigQuery using Google Cloud Dataflow. I'm going to go ahead and run this query. You can see these are all my tables over here in my You Look Marvelous data warehouse. So I have comments, line items, locations, orders, etc. And this query that I'm writing right now is looking at a few gigs worth of data. So it took just under 15 seconds, and I scanned 1.5 gigs of data. What this query did was, it's a relatively big query, no pun intended. I'm taking all of my orders, joining them to all the line items, and then all the line items to all the product information, and then all the comments for all those products, right? So 3 different joins across millions and millions of rows, and I'm trying to calculate the top 100 selling products based on sales, which is something people normally think about, like, well, hey, what are my top 100 selling products?
Are you making money?
Am I making money? Yeah, what products are making money? But what I wanted to know was, I want to rank those top 100 products also based on the average word count in the comments. So I have millions and millions of comments. I want to know the average word count for my top 100 selling products. So you can see that product ID starting with 417 has an average word count of 688. And if I look at my last product in the list, starting with 523, it has an average word count of 182. So it's a pretty big spread. And you'll see why this is important in a minute. The point here is, once you have your data into BigQuery, you can express any type of query that you want, and you don't have to worry about indexing, partitioning, et cetera. You literally load data, write query, period. So now that I've showed you how to build a BigQuery inside of BigQuery, let's go through a data analysis and data science journey to build that You Look Marvelous score. I'm going to flip over to another serverless product. This is Google Cloud Data Lab. It is in essence an optimized IPython environment that helps you interact with Google Cloud resources as well as any other resource that you would use inside of IPython. So here, this notebook is focused on building that You Look Marvelous score.
So we're going to do that emotional arithmetic here.
Yes, we're going to go from basically raw product view down to what is that score and how do you figure out what comments to filter.
Sure.
the first thing to look at inside of a data lab is we have these magic functions. You see this SQL and then module products. Here I'm defining a simple query, and whenever I run this query, it will go out, push down the query to BigQuery, and return those results. And I can easily take SQL results and convert them into Pandas data frames, which is the area that I'm more comfortable with. Like, I love SQL, I love writing queries inside of BigQuery, et cetera. I want to get this data inside of Pandas data frames so I can quickly do things like basic looking at descriptive analysis on top of the data. So I went out, I queried all of my products, and I want to look at their average star rating, right? The thing that we were influenced before. So here's all the products in my catalog, and you can you see things that are tightly clustered. At the 50th percentile, we're about 4.2, 70th percentile, about 4.4. Now, whenever I was doing the analysis, and by the way, this data is real, this struck me. I was like, oh, I sell products that people like overall. Like, you can see it is very, very tightly distributed. Like, if I didn't care about the products that I was selling, you'd probably see, some outliers, further down in the ratings.
That's true.
As a customer, if I was using ratings as a mechanism to disambiguate one product from another, you're headed down a bad path, right?
But too many choices.
There's too many choices, right? They all look the same. So the next thing I did was I took all of my user comments for those products and I ran them through the Google Cloud Natural Language API. And I'll flip over to that real quickly. Here's the product page, and you can go ahead and test this with any comments that you want. I pasted in a comment and I hit analyze, and you can see that the Google Cloud Natural Language API will provide you sentiment at the document level as well as at the sentiment level, so you can see that distribution that Sap was talking about before. It also picks out the entities, like this is skin cream, here is the sentiment against that entity. And it also provides you the syntax tree. So if you wanted to do some brute force lexical processing on this, you could say, hey, I want to look at the top number of verbs, or I want to look at noun phrases, or I want to look at the relationships of one syntax element from another. So you get all of this information back from the Cloud Natural Language API, and I can use Dataflow to ingest them into my data warehouse. So now, instead of just looking at scores, ratings, I'm now looking at sentiment, so I run a slightly bigger query, and this is what the distribution of sentiment looks like for those products. And again, whenever I was doing this, was like, oh, well, in this case, humans are doing the right thing. So I know I have very tight clustering that's in the positive range, so around, say, everything's, 50th percentile is around 0.9 or 1, which is good. Overall, there is strong positive sentiment for the products that I'm selling. So if we go ahead and pivot this, right? If you were the owner of this company, you're like, hey, this graph makes me feel good. 3, 4, 5 stars up until the right. I don't sell any garbage. I don't have any star ratings in 1 and 2. But as a customer, you're not buying the entire catalog. You're trying to buy one product. So that product that I just showed you on the You Look Marvelous site is this product right here. So how do you start to disambiguate between, say, 3, 4, and 5-star ratings? The averages and standard deviation, especially between 4 and 5-star ratings, they're almost the same. So again, this data isn't really going to help you as a customer. So the next thing I did is I needed more data. And I went and I used an open source library called Sirocco that helps you calculate scores for the wheel of emotions that Sap was talking about. So I ran all of my comments through Sirocco, and now I have a much wider data set to look at. In essence, I can write a bigger query. You see now I'm selecting all these emotions. And I'm going to go ahead and use a slightly different visual technique. Here I just have a heat map where I have the ratings on the vertical and I have the emotions on the horizontal. And what you see here, your eye kind of naturally gravitates towards, up and to the right. Here's where the most kind of density is around those raw scores. So I see a lot of joy, acceptance, surprise. This is good. This is what you'd expect. But if I start looking left, I'm like, wait a minute, why is there fear and some sadness showing up in this product?
Even though highly rated.
Yeah, that it was highly rated. And whenever I did this journey, I was just like, haha, I can go dumpster dive on even more data. But I had to take a step back saying, well, I'm trying to build a better ranking system for these products. Now, I did do that analysis, so yes, so people are fearful that they're not going to be able to afford the product because they got the product as a sample. So they got it from a friend as a sample, it was free, and then it's working for them, but now they're fearful that they may not be able to buy it. Or they're saddened because the product doesn't necessarily provide, the packaging doesn't provide the ability to get all the product out of it. There are all types of reasons why the emotion would pop up here. Now with this information, I now have the basis to start building a better sort order for my comments and products. Just for the heck of it, I ran a much bigger query. So this is Sirocco, the emotion analysis across all products, across all comments. So you can see like overall, up in the top right quadrant, people like my products, but there's a lot of fear and guilt and sadness, et cetera, that I may want to go dispatch to say my product quality folks and say, hey, go figure out what's going on here, right? Now, once I had this data, I went back to the customers, because we actually did this with the customers we're working with. I was like, what would you want to show? Like, if you knew the emotional makeup of these comments, what would you want to show? And they said, we want to show customers comments that are the most objective. In essence, the most information dense related to the product. So we did some research, and it turns out there's an inverse relationship between objectivity and emotion. So I tried to prove that. So I went and wrote a fairly complex query in BigQuery. So I'm basically pushing down this analysis. And what I wanted to do was find the top 2 comments per star rating that were the most emotional. So here's the answer to that. I love, love, love. I can't keep going on how much I love this product. I love this gel, et cetera, et cetera. This is a highly emotional comment, and you start reading it, and you're not really getting any objective information about the product. And you can see how verbose these are. In essence, a lot of these are a waste of time if you're going to show them to the end user. So we proved that, and then if we want to get to objectivity, well, what would this look like if I pulled out all the emotion? So I basically take that same query and I reverse it. Now these are the most objective comments in 5, 4, 3, 2, 1. So I can't say enough about how much I love this black line, or hydrates without a greasy feeling, absorbs into skin quickly, and is lightweight. This is a great comment. It's information rich, and it talks to the properties of the product.
Yeah.
So with this, I now have a way to go ahead and start determining what comments I want to show for a particular product. And the idea here was, whenever we were working with our customers, they said, well, we just don't want to show all positive comments. The first one we show is going to be the most positive and the most objective. The second one would be it would be the most positive with a little bit of emotion. So you kind of have a sense of like, yeah, this isn't just a robot that's talking about something. And then if I want to show negative emotion, I want to show emotion around things that I can control. I can't control if people are angry about packaging, right? Because I don't control the packaging, but I could help them if their emotion is, say, coming from fear, maybe about pricing or something like that. So once you have that data, you can start playing with the knobs in terms of what you actually want to show. All right, so now we have this score. We have this basis score, and you can weight it however you want. But we didn't stop there. The next thing that we wanted to look at was, could we determine some additional information about a commenter, as well as a user on a site, to potentially match them with comments that were more appropriate for them demographically? So the question would be, well, what could we look at? Well, what cities did they register from, et cetera? What types of products did we buy? What we wanted to look at was age range. So in the cosmetics space, cosmetics across age ranges, they behave differently, and people talk about them differently. And in our data set, we had 20% of our users who had self-identified into an age range, basically 18 to 26, 27 to 35, et cetera. So the question was, could we analyze that data to see if there was a difference between how, say, a baby boomer communicates versus how a millennial communicates? And if you could see those differences, then we could build a second knob to say, well, we only want to show baby boomers comments from baby boomers, and we only want to show millennials comments from millennials. So how would we do that? I'm going to flip over to another data lab notebook. This is the notebook that we built to do age classification. So using very similar techniques, I started my journey by pulling in a raw data set from BigQuery, in essence, all the comments and the buckets that users were in. So I only had 20% of my users had classified age, or had talked about age, so I'm trying to basically project and classify to the 80% of population. Here I'm using Keras, sitting on top of TensorFlow as well as BigQuery. And I'm going to go ahead and move down to the bulk of the model that I built. The idea here is that for every comment, I have n number of words, and I'm using an embedding model. I'm basically saying for the top 100 the first 100 words in that comment, I want to identify the most closest words to them. So it's a technique called embedding. So Saf, if you use the word like and I use the word love, those words are fairly close. If you use the word hot and I use the word cold, those words are fairly far apart. So the idea here is that if we can cluster comments based on the distance between those words, we could start seeing like, yeah, there's a difference between how millennials and boomers communicate. So I go ahead and I run my training data my training data to train this model. And there's some interesting things that pop out of it. So you can see here that I'm going ahead and I'm calling out to BigQuery, and I pulled back 21,000 comments. So I'm going to train on 16,000 of them. I try to distribute these the groups between group 1 and group 2, millennials and boomers. I try to keep the distribution even so I'm not creating some type of bias. And for those 16,000 some comments, it found 14,302 unique words, which is good. This is how I'm going to create my embeddings. One of the problems I ran into is that humans unfortunately don't spell correctly 100% of the time. So out of the 14,000 words, 3,200 of these words had null embeddings. So that people spelled moisturizer incorrectly or breakout, etc. So and basically, I've kind of taken the fidelity of the data that I had. I have higher fidelity, but I have less data to analyze. So I was kind of concerned at this point. I'm like, oh no, humans can't spell. But that's okay. I kept going. I kept training, and with the data, even with the quality issues I had, within 62%, I can accurately predict whether or not you're a millennial or a boomer. So here's a good example. So my predicted label was 1, which is a millennial. The actual label was 1. It says I'm a teenager, so I just started breaking out after I washed my face, etc. Now in this case, like teenager is a really, really good hint. Like if you see I'm a teenager, teen, etc., the clustering is going to be way more efficient, right? This one, boomer to boomer, you kind of read it and you're like, well, obviously there's some type of information, some type of pattern within that text that classified them as a boomer. And the great part is that you don't necessarily have to go and decompose why it is. You just know that you accurately predict it. And I think with some more tuning techniques and cleaning up these bad embeddings up here, I could probably get this to about 70%, right? Which is awesome. So now I have the ability to tune a knob and say whether or not you're a millennial or a boomer, and I also have knobs to tune whether or not you want to see emotional, or non-emotional, objective or non-objective comments. So using those two techniques, if you come back to the site, this is ultimately those two techniques are ultimately what is driving what is rendered on the site. On the back end, what we don't show in this demo, there's another seminar that has been done on it's called the Marketing Analytics Starter Pack, is showing you how to test whether or not what you built is effective using Google Analytics. So you can imagine if a user read these two comments or clicked on them and made a purchasing decision through Google Analytics, I could track all that click stream, do some basic A/B testing and saying, yes, this model that we came up with this way is the most effective one to drive sales. All right, let's get back into the slides and wrap up. Real quick note, so the Sirocco library that I used is Java-based. You can go out, it's open source, you can find it in GitHub. It talks about how you can use various indexing techniques and how you can leverage it with Dataflow. But you don't have to use it with Dataflow if you're running this inside of Apache Spark or something else, or maybe you could use it, you would even want to run it locally on your own machine, although that wouldn't be great for a big data problem.
Absolutely.
So I encourage you to go out and look at Sirocco if you're trying to look at the emotional analysis. If you just need sentiment information and or the lexical graph, go ahead and use Cloud Natural Language Processing. It is a great technique if you need that higher level information. So what did we show you? The journey was go ahead and ingest, fire up BigQuery. It's super simple. You basically say create data set, go ahead and load tables, and you can either do that in batch or streaming mode. BigQuery enables you to ingest data in real time, up to 100,000 records per second per table. And then go ahead and do some quick analysis inside of Data Lab or inside of Data Studio. We talked about doing some enrichment, so you could use the Cloud Natural Language API. You could also use our Vision API. You could do any type of enrichment technique that you want using Dataflow or another ETL tool. And then we get into the analysis piece. So you could do something like, with Sirocco, you could write your own analysis algorithms. And then once you get into feature development and modeling, you can do that inside of a data lab. You can do it inside of IPython. You can do it inside of R. It doesn't matter, to go ahead and create the types of features that you want in order to build a model. And then finally, if you need to go ahead and train and serve this at scale, you can go ahead and use Cloud Machine Learning Engine. So we went through a bunch, but this is in essence how we got back to this architecture, but now this has been contextualized in a retail scenario. Absolutely. But this would work in any type of scenario. This could be for life sciences, it could be for financial services, it could be for doing analysis over sports.
Yeah.
So with that, Sap and I want to thank you for your time.
Absolutely.
We've kind of gone from zero to emotions, and we understand how to quantify love. And with that, we're going to flip over to the live Q&A.
Beautiful, beautiful, beautiful. Good to go, guys. It's got to bump just a little. I wouldn't change the shot. It looks fine. It's geometric.
All right. And you've got the Q&A up there.
Okay. Well, now we have more gap on that side.
Now we got more gap where?
On this side. You moved it over so much that now there's like this much empty space.
Oh, I didn't.
No, this way.
I
This
didn't
way.
move it that way.
This way.
Tell me when.
Keep coming. That's good, but now straighten it out. That other way. Straighten it to the camera angle. Keep going. Good.
Okay.
All right, we have graphics ready.
You guys agree.
All right, stand by. We're coming back in 3, 2, 1.
So Eric, we talked about e-commerce, right? And in real businesses, you will have like hundreds of thousands of customers giving comments on your website and expressing their emotions and sentiment. How can I use Cloud Natural Language API to score lots and lots of comments?
Sure. So there are several techniques. I mean, the one that we talked about was ultimately you want to do this in the most parallelized fashion as possible because you have lots of things, and if you did them serially, it would take you lots of time. Mm-hmm. So using a product, say like Cloud Dataflow or another ETL tool, so maybe you wanted to use Spark or just a straight MapReduce job, you could go ahead and build a graph that will then go ahead and parallelize the analysis of each one of those comments. And that's the technique that we used here. We just used the Cloud NLP API and then build a function that says, okay, input comment, call function, and then you parallelize that. So you could effectively do a job that would say take 24 hours in total. You could run that job in 6 minutes of clock time.
Yep. That's great. And what if I need to do something more custom than what Cloud Natural Language API offers?
Yeah, good question. So Cloud NLP, as we showed you, you can get document and sentence level sentiment. You can also understand the syntax tree. If you need more, there are a bunch of already open source libraries out there, like Sirocco, and these, in some cases, play well with each other. So in fact, with Sirocco, I was using the output of Cloud NLP in order to drive Sirocco.
That's great.
Or you could build your own classifier. You could say build something that was more focused on identifying the subject of that emotion, if you will. And the point being is that anything that you do custom, you can then load it back into the data transformation or ETL system that you're using, say, for example, like Cloud Dataflow. Yep.
Can we apply this same technique to do like Twitter analytics? Like customers are talking about my brand in social media platforms like Twitter. Can I apply the same techniques to understand the emotions and the sentiment of the Twitter streams that are coming?
Yeah, definitely. And the path that one would take is basically ingesting that stream. So Twitter's a great example. So if you have access to the full fire hose or maybe even to the Deca hose, you need to be able to go and ingest and put that data someplace in a very low latent process. BigQuery is a great place to do that. So I can basically go ahead and read from those Twitter streams raw and ingest in real time into BigQuery, and then turn around and write your real-time analysis on top of it.
Got it.
Yeah.
And BigQuery allows you to do streaming analytics, pretty much. Do I need to do any configuration to make it happen?
No, you literally just create a table and start writing.
Wow.
Yeah, so
That's great.
yep.
And you showed Data Lab, but if I am a R user and I want to use any other tool, how do I connect to BigQuery to analyze my data?
Yeah, so there are two open source libraries right now to connect to BigQuery, and most recently Pandas also just added native read support. So now you can just go do Pandas like read from Google BigQuery, and all the underlying connectivity, et cetera, is handled by the library. So if you're in any type of environment that supports Pandas, that will work nicely. And there's also the similar API for R.
Wow, that's great. So no need to take like a data export to a separate data store. Just directly do it off.
No,
BigQuery.
if you're moving text files around like that, you've go find those libraries. They're quite easy to use. So
I think the last question we're going to take is how do I find more granular sentiment? I think the question is like, how do I understand emotions? I think you talked about the open source library, but can we just re-emphasize that piece? Like, how do you do?
Yeah, there are other libraries out there other than Sirocco, but
yeah.
in the case of Sirocco, the builder of it, his name's Sergey Sogolenko. He's a Googler, and he and I had several lunches about this topic, and he was just like, yeah, the existing or the analysis that the Pluchik built. And the research that he built was fairly sound. Like it was very well received, and it works well for lots of business domains. So whenever I was making the decision, I was like, I didn't necessarily need to do more. It provided the right level of granularity. What I needed to do was make sure that it was accurate. In my case, overall, it was. So, you kind of pick the tool that you need in order to solve the problem, but you may find that you need more granularity out there, and there are other open source libraries that you could use. So,
okay, that's great.
Cool.
And with that, we come to the conclusion of this Cloud on Air. Stay tuned for the next session. We are going to bring GCP closer to you. We have the next Cloud on Air starting from the Mountain View office live. So thanks for joining Eric and myself, and we talked about love. Spread the word of love, and happy Valentine's Day to all of you.
Take care.